Today I'm looking at this Philips PM3217 50 megahertz oscilloscope. This was my first real oscilloscope. I was using it for a few years, then didn't use it for a bit, then came back to use it, and I found that the triggering wasn't working. The display was okay, the amplifiers and so on, but just the trigger, it would always roll and basically not trigger. So I sort of put it aside for a bit, and I had some money to replace it with a Rigol, but I did try to have a look at servicing it a bit later. This is like 10 years ago or something, and I decided to replace all of the electrolytics pretty much that were sort of the classic blue Philips electrolytics with replacements. Probably went a bit overboard. I'd probably be a bit more selective now. Anyway, that's what I did. So on the main board here, and the power supply at the back. So the power supply is, well, there's a switch mode supply that generates a bunch of voltages, but that in itself is fed by a low voltage input to that board via this transformer, which you can have from the mains or just a DC 12 volts input directly, so you could run it off a battery, say. So that's the general principle of the power supply. Anyway, I'd replaced all the capacitors, I'd plugged it in, and pop, something went bang on the power supply at the back, I suspected. At that time I was busy, got busy, as I say, I'd got the other oscilloscope, so basically I put this right to the back burner, I put it away, forgot about it, pretty much. Anyway, 10 years later is now, and I thought it's about time I work out what I did wrong, and see if I can make some more progress on it. This was quite a nice analog oscilloscope, so it would be nice to get it working. It's got a dual time base, delayed time base, and dual dual display, so you can display two waveforms, and then this delayed time base thing where you can take a part of the waveform and then display part of that in detail. Well, maybe I'll show that if I can get it in a working state. But first things first, let's have a look at the back and see what happened. Alright, so this is the power supply section. So the switch mode supply and various rectifiers that tap off different voltages, and then a bunch of smoothing capacitors through inductors to filter out the ripple. So this one here, I don't know whether you can see, that's suspicious, that is bulging, so that seems to be wrong. Okay, so I did look at the PCB in the schematic, and here this is pointing this way, positive at the top end, which is exactly what I've done in real life, and similarly for that one, pointing down. So I've replaced these two according to this service manual. However, on closer inspection, I tested where the traces went for these two capacitors, and it turns out that these are swapped over on the actual physical board. So at some point there's been some revision, and this manual doesn't correspond to the reality. So, like an idiot, I've trusted this service manual and not what was there on the board. So for a second time I found that I incorrectly didn't take proper note of the actual board when I was replacing things, and not assume that the service manual I've got is the canonical truth. Okay, so next thing is to take this board forward a bit so I can get to the capacitor leads and unsolder them. I'll replace this one. I've found that when I bought this value, I got a spare, so I can replace this one and put it in here with the opposite polarity and move this one. I'll test it and swap it around in this position. So that's what I'll do. Alright, so I've moved those capacitors in this position here and hooked up the power supply from the transformer, and it's looking pretty good. So it's on its side, but I've hooked the A input up to the calibrated test point here, and as you can see, it's well, let's get the cable out of the way. You can see it's triggering okay. The time base is working there, the Y amplifier. Oh, maybe that switch is a little bit noisy still, but it's essentially working. And that's calibrated position. So yeah, maybe I'll just check some of the functionality and the switches, maybe try and put some spray cleaner in there, and then maybe I'll sort of show some of the functions. Just another thing to point out, I remembered that some time ago I needed to replace this capacitor. There was a Reefer brand mains transient suppressor. Those are famous for cracking the kind of semi-transparent plastic cracks, and either fails with smoke coming out, or anyway, at least you can see cracks appearing, and I can't remember whether it actually did explode or whether I just noticed it in just some tests I was doing and servicing checks. Anyway, yeah, so that's something, if you've got one of these scopes, to check and probably replace as a matter of course, because if it hasn't failed yet, it will do. Yeah, that's it really. Just wire it up there across these the switch for the voltage selection. Alright, another thing I've just remembered that I did many years ago when I was servicing this. I don't know whether it was related to the capacitor that I need to replace, but at some point I found that there was no power from the transformer, and I was fearing the transformer had burnt out for some reason, but actually it hadn't. There was a thermal fuse here, and I think there's something that sort of slots in, or there was something that slots in here, and this is obviously to protect against the transformer overheating, so it's thermally close to the source of heat, and will blow if it gets too hot, and so on. So I replaced it with a fuse that I'd got from somewhere that seemed appropriate. I can't remember the details, but yeah, I've soldered that in there into this point inside there. So that's something to check anyway. That there's a fuse there that's not obvious inside this this module here. While I was around the power supply, I thought I would have a look at the service manual, and there's a description here of the tolerances of the outputs of the power supply module there, and there is one control where you measure the voltage on this capacitor. That's the 12 volt line, and you can make an adjustment. So let's just have a look and see how close we are on that. So I've just had this running for a few minutes. That's the 12 volt test point there on that capacitor, and this is the adjustment here, this one. So it's actually gone closer to spec just in a minute, but we can just tweak that a bit more, and there we go. Might as well have it as close as possible for the 12 volt line. There's clearly a lot of preset adjustments that you can make to calibrate and optimize the performance. I'm not going to go through all of them, but I do want to point out a couple maybe that could be useful to check. So on the front you've got the square wave output. That's useful for calibrating the edge response of the times 10 probes with the adjustment there. That's typical on all oscilloscopes really, but it does specify the output voltage 1.2 volts peak to peak, so that can be useful to check the calibration of the vertical amplifier. So I thought I'd have a go at checking that, and with my Rigol I have just made a small adjustment to that. So now you can see it's 1.2 volts peak to peak within these divisions here, 1, 2, 3, 1, 2, 3. There's a little bit of noise there, so the actual reading here is 1.22, which it would be measuring at the top and bottom of the noise. So I've kind of put the divisions there in the middle of the noise. I think that's probably the best thing to do. That is adjusted here by this preset, so if you need to tweak that, that's where to do it. This adjustment here on the bottom of the power supply is astigmatism. I'm not going to play with that, I don't think this one needs it, but that is useful if when you're focusing you can't get a progressively smaller circle if it goes into an oval and then you adjust it further and it goes to an oval the other way. That's the kind of problem you get with a mismatched astigmatism, and so that should adjust that problem, but as I say, I don't think I need to tweak that. This one is geometry. We'll have a look at the service manual now and see what it says about that. So here we see comments on the astigmatism that I mentioned a moment ago and the geometry adjustment here. So you can see we obviously want to end up with a kind of scan where a horizontal line or waveform would be the same width and the same position, whether it's in the middle or the top or the bottom. So in this scenario I would expect the left hand part of the trace to sort of come in here if this was a problem, and conversely pull out. So I'm going to have a visual check on that geometry, but I don't think that was a problem, so I don't expect to need to adjust that. But if you do, that's the control on the power supply. Now looking at the calibration of the internal amplifier based on this now calibrated voltage, we can see similarly 6 divisions there on the vertical scale, so that's looking like as good as we're going to get on this kind of scope. So yep, no need to adjust anything on the vertical amplifier. Of course that's only one channel, that's the A channel, so we'll have to check the second one as well. So looking at this trace again through the B amplifier, you can see it actually goes from ground down to negative, interestingly. I hadn't noticed that before. But anyway, you've got on the B channel this extra function on the position knob, which I'll make sure that top is ground, and then if you pull it out it inverts. So now everything that was negative is positive. Okay, so that is useful because you've got a function to add A and B here, and so you can basically do a negation if you've inverted one of the channels. But you may notice that in the inverted mode it jumps slightly from ground. I mean this line should be always on the ground level, so there is an adjustment trimmer that should be able to remove that slight DC offset. So we'll look in the service manual for that. So here's the service manual. Pull to invert, adjust R647, which, if we look closely, is this here. So let's find that on the board. So that should be this one. So I'm going to have a tweak of that and see if I can get rid of that offset. There you go. So that's much better balance. So that's that done. Good. I'd like to describe one of the more advanced features. Okay, so a lot of oscilloscopes have two channels, at least the analog ones, two channels. And of course you can display A or B, or choose to display both at the same time. Now, there's only a single beam in here. Some very high-end analog scopes had a dual beam, which were completely independent channels on the display, but most weren't. And in order to display two waveforms, A and B, you would either have to do a chop or an alt. So either it would draw one and then draw the second and do that very quickly to give the impression of two waveforms, or I mean that was a good technique for waveforms that were quick, so it would skip across and back without you noticing. But for very slow time-based signals, you wouldn't want to see one waveform being drawn out and then go into the other one. So what it does is there's an oscillator that alternates between the two signals, and so it draws a bit, then it jumps down, draws a bit of the other one, draws another bit of A, jumps down, draws another bit of B, and that's the chop mode. Anyway, that's all pretty standard, so that's not particularly advanced. But what this does have is a dual time base. So looking at this single channel B, we're not going to look at channel A at all in this. Single channel A, normal operation, main time base is controlled over here. So what then is this delayed time base for? Okay, so let's turn it off. Turn it from the off position, and you can see that the main waveform goes dim, but you see a little spot there. So what that is doing is that is showing part of the main waveform that you are interested in zooming in to, essentially. So this is all in the analog domain, remember. So what you can do is adjust the delayed time base. I'm making it basically slower, or sampling more time, if you like, and you can see it's covering more and more of that original waveform. So the idea is that you would want to see some periodic signal, but then zoom into some particular detail. We're going to zoom into that edge, right? Because normally things like edges are of interest. Okay, so that is kind of selecting, if you like, the bit of the waveform that we are interested in. So in order to actually see it, we then switch from the main time base here to the delayed time base, and that there is the edge of that main waveform. And if you if you depress both of these buttons together, you get the alt time base mode, which, as you can see now, gives you the main waveform with the selected part and the display of that selected part. And then you can adjust the separation with this control. And is there anything else to... Oh yeah, this control here, this fine control, adjusts the time from the trigger point, essentially. So as you can see, as we're moving forward in time and backward in time, we're seeing the section magnified here. So this is quite a sophisticated way of looking at a fine detail of a larger portion of the waveform. Now on the camera there's some flashing, flickering. That's not in real life, it's just the extra flipping and oscillating that the display is doing. That's not visible in real life. So yeah, that's fairly advanced feature, and you can do all sorts of other things that I've never used, never will use, I'm sure. Externally triggering on events for the main and delayed time base and all sorts of things there. But yeah, that's an interesting feature that only the higher end scopes had. Well, looking through the service manual, there's plenty of other pages describing all of the other preset potentiometers and adjustments. So the time base, the delayed time base, the triggering, all sorts of things here. Checking the gain and the frequency responses here, various things to adjust, and the bandwidths and crosstalk minimization and all sorts of things. I'm not going to bother with all of these. It looks too time consuming, really. I don't really need this to be super high precision. Maybe if I get some free time, I'll have a go, but yeah, I don't think I need to do that. I'll just call this a repair finished. Just one final thing. If you have one of these scopes with this leather pouch for the oscilloscope probes and so on, just make sure you don't store it anywhere that has mice, because apparently they like to eat this a little bit. But anyway, that's it. Thanks for watching, and yeah, see you in another video.